Yes, good morning to all. My humble pranams to my teachers. Today, in this video, I would like to tell about the principle of least squares. Principle of least squares or method of least squares. Or method of least squares. So let xi yi I equals to 1 to so on n are given n data points where yi is dependent variable, xi is independent variable. In curve fitting, the general problem is to find out the functional relationship between yi and xi. So in such a case, in the curve fitting, we have used method of least squares, right? So the principle of least squares, is used to fit the curve of the form yi equals to f of xi a0 a1 a2 so on an, where I equals to 1 to so on n are n unknown parameters to a set of n sample paired observations xi yi I equals to 1 to so on n from a bivariate population, right? It consists minimization of residual sum of squares, so that is E equals to summation I equals to 1 to n yi, that is the actual value, this is the estimated value, this is the square. So if you are expanded this form, summation I equals to 1 to n yi minus of, the functional form is f of xi a0, a1, a2, so on an, the square subject to variations in a0, a1, a2, so on an, right? So the normal equations for estimating a1, a0, a1, a2, so on an are given by dou e by dou ai equals to 0. So I equals to 1 to so on n. So you are getting n normal equations. If you solve these normal equations, then you find out a0, a1, a2 and so on, a1, a0, a1, a2, so on. So this procedure is called method of least squares or principle of least squares. So this is about the principle of least squares. So thank you for watching this video.